In this explainer, we're diving into the actual, rigorous world of true prompt engineering. You are shifting from being a casual user to a systems architect, and trust me, that requires a completely different mindset. I want to hit you with a bit of a reality check right out of the gate. Think about the old way we used to do things. We've relied on super formal Python syntax, right? Strictly defined functions like def generate summary. But today, we're using natural language. We're typing things like system, you are an expert editor. Now, it looks like plain English, but don't let that fool you for a second. This prompting, it's the new compiled code. It demands the exact same level of respect, testing, and validation as any traditional software. You're not just typing anymore. You are literally programming with words. Okay, so here is your orientation day syllabus. First up, natural language is code. Then, looking under the hood. After that, the architecture of prompts. Moving on to calibrating and scaling up. Then, defensive engineering and risks. And we'll wrap it all up with the iterative engineering cycle. Let's get into it. Section 1. Natural language is code. The paradigm shift. So, the fundamental paradigm shift you absolutely need to grasp today is that incredibly small, seemingly insignificant changes in how you phrase things, your formatting, your specificity, they yield massive variations in the output. It's exactly like how a single missing semicolon in traditional code can just totally break a build. A poorly phrased instruction will completely derail your AI model. You have to know the engine you're driving. A base LMM, that relies on pure next token prediction. It literally just wants to finish a sentence. You say I, it says am going to the store. But instruction-tuned models, those have been refined through RLHF, reinforcement learning from human feedback. Their whole behavior shifts from just continuing text to completing tasks. The big takeaway here? You are no longer just predicting text. You are commanding a highly tuned task engine. Moving on to Section 2. Looking under the hood, the mechanics. Listen, you can't build a reliable race car, let alone drive one at top speed, if you don't actually know how the engine works mechanically. So let me ask you this. Do you think the model actually reads your text? Because it doesn't. LLMs predict tokens, not text. Think of tokens as the actual gears turning inside the machine. And notice how white space, punctuation, and formatting, they actually change the token boundaries. Controlling that structure using bullet lists or JSON, that directly alters the model's parsing logic. If your output is coming back as complete garbage, well, it's highly likely you just didn't respect the token mechanics. All right, Section 3. The architecture of prompts. Building the blueprint. Grab your hard hat, because we are moving into the construction phase. A professional prompt is not just one giant messy paragraph. It's built in 3 strict hierarchical steps. First, you have the system message. This is where you set the persona, the role, and all your overarching constraints. Next up, the user message. This delivers the specific task and explicit instructions for right now. And third, the assistant message, which houses all the historical context and prior conversational turns. Keep these totally separate in your mind. So here is your complete blueprint. As you can see, a prompt is really a structured sequence of messages. By distinctly separating that system role definition from the immediate user task and the assistant's history, you dramatically reduce the cognitive load on the model, and less cognitive load means drastically fewer errors. Now, structural integrity is literally everything here. Mixing a messy instruction directly into your source text? Total rookie mistake. It completely confuses the model. Instead, you absolutely must use what we call the primary content pattern. You do this by explicitly labeling your instruction and your content. You've got to use delimiters like XML tags or Markdown to isolate what you want the model to do from the data the model should use. Keep them separated. Section 4. Calibrating and scaling up. Precision control. Okay, so you've got your structural integrity down. Building a prompt that works exactly once? That's the easy part, but building one that works flawlessly 10,000 times, that requires some serious precision control. How exactly do we make sure this highly creative, highly variable AI engine actually follows our strict formatting rules perfectly, every single time? Honestly, it's one of the biggest challenges in generative AI right now. And the answer is progression through example-based prompting. Step 1 is zero shot. That's just giving the instruction alone. It's fast, sure, but it has super high variance. Step 2 is one shot, where you provide the instruction plus one perfect example to establish a baseline pattern. But if you want to reach true engineering-grade reliability, we have to go to Step 3, few-shot prompting. That's the instruction plus multiple diverse examples. Remember my golden rule here. Show, don't just tell. It is by far the most efficient way to enforce strict style constraints. And to scale that consistency, we start using prompt cues. Just by ending your prompt with something like top 3 facts, 1, you practically force the model's starting sequence, which completely dictates the immediate output format. Combine that trick with templates. By using bracketed variables, like topic and grade level, you essentially create a highly maintainable piece of code. And that's what allows a single well-engineered prompt to scale reliably across thousands of dynamic inputs. Section 5. Defensive engineering and risks, anticipating failure. All right, time to adopt a really serious mindset. Listen to me carefully on this one. If you don't anticipate the inherent failures of this engine, you will eventually crash the car. These models are incredibly powerful, but they are fundamentally flawed. First up, stochasticity. Just a fancy word for variance. The underlying cause is the model's inherent randomness. The fix: apply templates, use those few-shot examples we talked about, and lower your temperature settings. Next, fabrications or hallucinations. This happens because the model feels pressure to answer even when it's missing the actual context. Your engineering fix is to require explicit citations or integrate RAG, retrieval augmented generation, to pull real facts from a database for the model to use. Lastly, model version drift. The provider updates their API and boom, your prompt breaks. You defend against this by building explicitly testable, highly structured prompts that remain portable across versions. Let's drill down into 2 super specific defensive tactics. First, the fallback. You absolutely must give the model an out. Tell it explicitly, if unknown, respond insufficient information. This completely eliminates the pressure to hallucinate an answer. Second, you have to combat recency bias. These models heavily prioritize whatever information is located at the very end of a prompt. So the trick here is to always place or even repeat your absolute most critical constraints at the very bottom. Section 6, the iterative engineering cycle, the sandbox. All right, I think it's time to hand over the metaphorical keys. I've shown you the theory, so let's look at where real professional engineering actually happens. Hint: it does not happen in a basic chat window. Real engineering happens in an experimental sandbox. Think Jupyter notebooks connected directly via APIs. This is exactly where you can run your prompts repeatedly in total isolation. You can systematically test temperature changes and tweak parameters completely outside of standard chat interfaces. You'll need to build and maintain a standardized prompt library right here. And while you're working in that sandbox, you are going to live and breathe this never-ending loop. Draft the initial architecture, observe the execution, revise by tweaking tokens, adding delimiters or injecting those cues, and finally, evaluate by measuring the output against strict quality rubrics. First drafts almost never scale, rookie. You have to treat your prompt like a living codebase that requires continuous testing and refinement. To wrap up today's explainer, I want to cement the engineer's manifesto into your brain. Consider these your ultimate marching orders. 1. Interface, not chat. Treat your prompts as a programmable interface that requires real architectural rigor. 2. Strict separation. Always isolate your instructions from your data using clear delimiters. 3. Guide the engine. Prime your output using few-shot examples and highly precise cues. And 4. Defend and iterate. Anticipate fabrications with safe fallbacks and test relentlessly in your sandbox. And that leaves us with a really fascinating thought to chew on. As we all get better at writing these natural language instructions to guide these powerful AI systems, that line between being a user and being a programmer starts to get really blurry. If prompts are the new code, what does that mean for the rest of us? It's definitely something to think about. Thanks for tuning in.